Thanks for joining, everyone. My name is Pete Anzalone, North American Sales Director for Thermo Fisher Scientific. Today, we're going to cover the Thermo Scientific Niton DXL 800 benchtop XRF technology. This analyzer is predominantly used for the precious metals industry, serving refineries, gold sellers, resellers, and the jewelry industry. So today I'm going to give you a brief demonstration. As you can see, it's a benchtop. You have the aesthetics of a two-sided closed beam system where the customer can see the glass from the other side of the desk, and the top has a very enclosed closed beam system. Here we have two reference standards that I'd like to be able to go through the analysis. And this is the first standard, which is a certified standard, and it's 99.9% gold. So as we offer this up, it's got a camera, line this to the center of the DXL 800, close the lid, and simply start the analysis. And as you can see, it's going through the analysis. You have the X-ray hitting the surface, it's sighting the atoms, and what's coming from there is a spectrum. And from a very complicated algorithm and detector, it's telling us that it's 99.9% gold. So this is the pure standard, and that's your reference standard for showing the customer that the instrument is calibrated as such. Then when you look at different blends, the most common is 14 karat, and this is based on the percentage of gold. So 14 divided by 24 gets you 58.5%. So this is a 14 karat reference standard. Same process, put it in the center of the camera, close the analyzer, and simply go through the process of doing the analysis. And as you can see, within seconds, it's determining the other elements that you would find in the material. So this is a good representation of 14 karat, which is a blend of 58% gold, 25.9% silver, copper, and zinc. And these are typical blends for annealing the characteristics together. So at that point, you've referenced the customer that the material and the analyzer is calibrated and certified against those. So what are we trying to do? In essence, authenticate people's jewelry. So this is a Cuban link chain. No idea what the carat value. This would be weighed, and at that point, it's going through the analysis, exactly the same as the reference standard. And as you can see there, it's 14 karat, and it's a blend of plus or minus 0.6 to get to the 58.5 required for gold, copper, zinc, and silver. If you look at a piece, material as it goes up to 24 karat is softer. So if you had the pendant being 10 carats and the chain being 18 karat, the pendant would actually wear down the chain, which is not good. So we need to make sure that the pendant is indeed 14 karat. Pop this in the center. Press the analysis. As you can see there, it's over 14 karat, but within the tolerance level. So gold, in actual fact, is 61.3%, copper is 28.7%, zinc 4.9%, and silver 4.4%. That is the chemistry required for 14 karat. So what else does it look at? Not all this shiny gold is authentic. There's a number of counterfeits, and although this looks very similar to be a gold piece, we can put this under the same test. Straight away, within seconds, there's an audit process in place that tells us this is not indeed 14 karat. So you can see that there's 67% ferrous, chrome, nickel, and titanium. Those indicate that it's not gold on any level whatsoever. This is a bench stop, typically in pawn shops and jewelry manufacturing for authenticating the gold. But we also have handheld XRF if you needed to have portability. So thanks for this opportunity.